Afternoon, children. Today I want to start the lesson playing with magnets IIT topic, and previously only we have discussed about this in regular class. Yes, physical science. Okay, that first lesson is comes under biology. I want to start physics lesson playing with magnets first. Okay, na? In this playing with magnets, we have discussed already about the natural magnet, magnets. Yes, magnet in natural magnet is what, Nana? Natural magnet. What is the name of the natural magnet? Who invented that one? Lodestone magnet invented by Magnus. Okay, lodestone invented by Magnus. Okay, that is the natural magnet. Lodestone is the natural magnet. So Lodestone, lodestone is the natural magnet. Who invented that one? Magnus. Magnus invented that, and this is the natural magnet. This is about 4000 years ago he invented. And magnetic materials also, you know what are the magnetic materials? The materials which are attracted by magnet are called magnetic materials. Yes, some examples you can say: cobalt, nickel, steel, iron. These all you know. And while coming to the non-magnetic materials, the materials which does not attracted by the magnets are called non-magnetic materials. Examples of those are stainless steel, plastic, rubber, paper, gold, silver. These all are non-magnetic materials. I think you already remembered that one. You kept in your mind in that previous explanation only. We have discussed regular class. And coming to the magnetic poles, these are the two ends of the magnet. Yes, these are the two ends of the magnet. The two ends of the magnet are called magnetic poles. Those are south pole and north pole, namely. And coming to the types of magnets, so lodestone is the only one natural magnet. Remaining all are man-made magnets, artificial magnets. Yes, and magnets can also be made using electricity. Also, those are called as electromagnets. Magnetic compass, which is indicating for, which is an instrument and which indicating the directions. Yes, used to find the directions, and it has a thin magnetic needle supported from a pivot so that it cannot rotate, it can rotate freely. Supported a pivot, it can rotate freely. Due to that we can find the directions. Why? Because earth is acting itself as a magnet, which is exactly with opposite directions to our normal directions. Earth itself acting as a south side north, north side south unde vidhanga oka magnet laga work chestundi earth. Yes, yes, reverse magnet property it is having, itself it is acting itself as a magnet. Very good, Navneet Nayak. And properties of magnets: a magnet attracts magnetic materials towards itself. A magnet attracts magnetic materials towards itself. Is it correct? Magnet attracts magnetic materials towards itself. And storing magnets: how can we store a long period of time? By without loss of magnetic property. To avoid this, we have to store those with soft iron pieces called keepers. We have to keep that magnets in soft iron keepers. In that we kept means at that time we can store the magnetic property for long time. For storing of magnets we have to use iron, nana. Iron pieces we have to use. Iron pieces lo pedte magnetic properties loss avakunda for long time we can store. And coming to the precautions to protect magnets from losing their magnetic properties. What are the precautions we have to take? And these all we doesn't discussed in that regular class. Yes, storing how to store magnets we doesn't discussed. Is it there? Storing magnets? No. At that time we has not discussed. We did not do that. We did not done. And coming to the precautions, here precautions: never drop magnets from heights. So if we drop like that, the magnetic property will lost, may lost. And coming to the never heat a magnet. By heating also we may get loss of magnetic property. And do not hammer a magnet. Do not break that one into two pieces. So in that manner also we may lose the magnetic property. And certain items such as CDs, DVDs, debit cards, credit cards or ATM cards, these all are audio and video cassettes and mobile phones contain magnetic material. Keep them away from magnets to prevent damage. So we in these materials, whatever I told now, CDs, DVDs, debit cards, credit cards, ATM cards, these are all having magnetic material inside of there. So that's why if we keep them uh, near the magnets, magnets may lose their magnetic property by attraction and repulsion. సో డ్యూ టు దట్ ఈ మ్యాగ్నెటిక్ మెటీరియల్స్ ఉన్న థింగ్స్ ఏవి కూడా మ్యాగ్నెట్స్ కి దగ్గరగా పెట్టొద్దు. డ్యూ టు దట్ వీ మే లాస్ ద మ్యాగ్నెటిక్ ప్రాపర్టీస్. అండ్ వాట్ ఆర్ ద యూసెస్? ఇన్ రెగ్యులర్ లైఫ్ వీఆర్ యూజింగ్ magnets in magnetic compasses, sailors and navigators to directions. Yes, navigators, sailors, those people will use magnetic compasses to know the directions with them. And magnets are used in magnetic toy stickers, refrigerators, doors, we are using in our daily life. And magnets are used for separating iron from ores. How can we separate iron from ores? By magnets only we can separate iron from the soil, and all iron fillings may collect by a magnet. And electromagnets are used in generators, motors, loudspeakers, TV sets, fans, mixers, electric bulbs. In all the ways we are using electromagnets. Using electricity also we can make magnets, those are called as electromagnets. Those are useful in these all instruments, all type of things. And electromagnets are used in cranes to lift heavy iron bars and separate iron objects from scrap. And eye doctors also use magnets to remove teeny iron pieces that have accidentally fallen into the patient's eyes. If teeny iron fillings, any small iron particles or dust particles enters into the eyes, at that time doctors will remove with the help of magnets only. So in that manner, these are the uses of the magnet. And coming to the permanent magnets and their kinds: bar magnet, magnetic needle, aluminum case, and this magnetic compass, horseshoe magnet. These are all the some artificial magnets. And permanent magnets means here there are two kinds of magnets: artificial magnets and natural. Natural are pieces of magnetite. Fe3O4 is the formula for that. And coming to the artificial magnets are made from steel or its alloys with cobalt and nickel, because those are strong magnetic materials. In our regular class also I told you, the permanent magnets, strong magnets are made from strong magnetic materials like steel, alloys, and nickel. With the help of those we can make the permanent magnets. And coming to the artificial magnets, here we have different kinds. In our textbook also we have so many diagrams. Is it correct all? Are you listening? Yes, very good. And coming to the bar magnet, here lot of information they have given in these IIT books. So for this purpose only you have to follow these books, because some extra more information than our textbook we can observe in this. The ends of the bar magnet are marked with letters north and south poles. This means that if we are freely suspending those, the end marks N will point towards geographic north, and the south will towards south side. That means the earth itself is acting as a reverse magnet. And coming to the magnetic needle, which shows the a magnetized steel needle. That one is a magnetized steel needle mounted on a sharp pivot. So it is commonly employed for testing polarity of the given magnet. How can we test? By checking how the suspended bar magnet showing directions. In that manner, needle also will show the opposite arrow mark indication. They are having on the top of that north south in this manner. Magnetic needle is looking like this, Nana. See. So here this is also artificial magnet. And horseshoe magnet. So it is derives its name because it is bent in the form of horseshoe. దానికి ఆ నేమ్ ఎందుకు వచ్చిందంటే it is looking like that horseshoe. More powerful than bar magnet because both north and south poles face each other. So that's why it is more powerful. And compass, which is indication for directions, for showing directions. Navigist, here they I told you in the uses. So in forest, if we enter into a deep forest, or if we enter into inside of the water and top of the sky, so at that time we cannot identify the directions after reaching certain distance. So at that time we need magnetic compass to know the directions. General definitions of bar magnet: Here actually we are considering a bar magnet. I think you are observing screen or it is not clear. Are you observing screen? Okay, I'll send the video afterwards. And here pole. Each end of the bar magnet is called its pole. Geometric pole means here the geometric end of the bar magnet called its geometric fold, and magnetic end is called a magnetic fold. For example, geometric end means here we can observe. Yes, here. And magnetic pole is at a north pole. Inside we can observe magnetic pole. The point situated slightly inside the bar magnet. This is magnetic fold, and the ending of the magnet is geometric pole. Okay na? Is it clear for you? Ending of the bar magnet, complete ga magnet end అయ్యే దగ్గర geometric pole. Inside మనకి north pole, south pole. Inside of the magnet north pole and south pole, those are magnetic poles. Magnetic axis is middle of that magnetic axis. If we horizontally draw a line, that is magnetic axis. Imaginary line joining north and south pole, exactly middle of that is axial line, also we can call xy direction magnetic axis. And equatorial line, the line passing through the center of the magnet is called equatorial line. Equator, we can also call equator, which is perpendicular to that magnetic axis. Geometric length means mottam length nana, entire length of the magnet. And length of the magnet means north pole to south pole mottam enta distance undo, that is length of the magnet. And here one relation is there, magnetic length is equals to 5/6 into geometric length. Which one is bigger nana? Magnetic length is more or geometric length is more? Geometric length is the distance between two geometric ends. The distance between the magnetic poles is called a length of the magnet. Here magnetic length is 5/6 times of the geometric length. That means geometric length is more. It is some magnetic length is somewhat smaller. Why? Because here we are multiplying with a 1 below. 5/6 is less than 1 or greater than 1. Fractions you have completed in maths. Yes? 5/6 is more than 1. Na? Improper fraction or proper fraction? 5/6. Proper or improper? Improper fraction. Huh? Improper? Proper. Why? Because denominator is more than numerator. That's why it is proper fraction. And 5/6 is less than 1. So that's why magnetic length is automatically lesser than geometrical length. Why? Because inside only we are considering. Poles లోపల ఉంటాయి. Magnet పెద్దగా ఉంటుందా? Poles కన్సిడర్ చేస్తే ఏది పెద్దగా ఉంటుంది? Inside less. So magnetic length is less than geometric length. So in that manner we can observe. And properties of magnet: attractive property, directions it is showing, poles existing in pairs. And how to make a bar magnet with our own? How can we make? With the help of another magnet we are keeping. And uh, uh, yes, very good. Very nice, Navanit Nayak. And coming to the two divided touch method, too. Double touch also we can use for this. So take a bar magnet and touch it from two sides. Then we'll get the two double poles like this. Here north south inside and north south. In that manner also we can make, by using two magnets also we can make that in that manner. Whatever we have in textbook, in that manner also we can do. Another method is take two magnets, two bar magnets and a big rod, and start one with south side, middle to south, one end to north end ఏమో south end side పెట్టుకోండి, and another one south side తో start చేయండి. Rub up to middle, two up to middle. Is this diagram visible to you? So in that manner we have to do. So in that manner also we can make that magnet materials, artificial magnets we can also made in this magnetization. This method is called as magnetization. So in this manner also we can do